this lesson we will look at grouping data. In this lesson we're going to look at methods of grouping data for ease of analysis. Now let's imagine that we had 20 students that took a maths test and they had scores out of 20 as per below in the table, and we were asked to put this into a frequency table. Now we've already learnt that a way for doing this would be to use a tally chart. But if you have a look at the tally chart that we've created here, you can see that it's not the most efficient or effective way of creating a frequency table. There are just too many different options for us to be able to do this easily. There are just too many variables and not enough frequency within those variables to make using a tally chart worthwhile. We have a different option to look at though. So instead of a standard tally chart, let's look at grouping data instead. When we have a lot of data, it can be much more convenient, quicker and easier to group the data as opposed to calculating them individually. So in this section we've split the groups into 4 separate distinctive groups. We've got mark, tally, in other words how often, and then frequency. So mark 0 to 5 is one group, the mark 6 to 10 is another, the mark 11 to 15 is the third, and the mark 16 to 20 is the fourth. These are 4 equal groups. So let's have a look at how the tally works. So let's look at that now. In the area marks 0 to 5, we can see that the score 4, the score 3 and the score 5, marked here, are the only scores in that group. So that gives us a tally of 3 marks, a frequency of 3. If we then look at the next group, 6 to 10, we can see that there are 6 different numbers that are in that grouping. And then in 11 to 15, as you can see, there's also 6, and then 5 between 16 and 20. This shows us that there are 3, 6, 6 and 5 in terms of the frequency, and we double check that to make sure that that matches everything and we haven't missed anything. And we know that 3 plus 6 plus 5 is 20, so we know that we've actually got a double check to make sure that everything is balanced. This really is a clear and easy way to handle discrete data. However, what happens if you want to group continuous data? So let's look at this example. In this example we've got the heights of 20 tulips in centimetres that are correct to 1 decimal place. Now we have to put this data into a frequency table. In the same way that we had groups of discrete data split into data ranges, we're going to create continuous data ranges in the list below, and you can see that we've created it from 13.5 to 14 and then all the way down. Just a quick word here about the data ranges, or as they should be called, class intervals. So the first line we have the class interval 13.5, and it goes from 13.5 as far up but not including 14. So that would mean that this data interval would be for 13.5, 13.6, 13.7, 13.8, 13.9, which is 5 separate scores but not 14. If the score was 14, it would go into the second class interval. And the second class interval says 14 up and as far but not to include 14.5. I hope this makes sense. Let's now tally up the numbers within that first class interval or data range. And you can see that there are a total of 4 giving us a tally of 4 giving us a frequency also of 4. Also note that the number 14 we didn't calculate because it's going into the second class interval, not the first. Having completed the first class interval, we can very quickly complete every single remaining interval to finish up the table. And when you've completed it, you'd end up with something like this, that also, if you add up the frequency, comes to a total of 20. This is a very important method to do to make sure that you don't miss any of your data collection, because if you make sure that the total frequency matches the original amount in the data range in the beginning, you know that you've actually got it correct and you've not missed anything out.